So in final examination, I will make 5 multiple choice problems. Each one represents each chapter. Chapter 1, Chapter 2, Chapter 3, Chapter 4, Chapter 5. And the problem would be in acoustically large space 1, then must be diffuse field. Radius of reverberation represents something. Reverberation period certainly measures something. And I will ask you pick up the right one. That can be all, that can be 1, that can be 0. Okay? If you make a right answer, you will get, for example, 10 points. If you make a wrong answer, for example, if you pick a 1, 3, 4, and the 5 is a correct answer. And if the correct one is only 3, then you will get -2 or -1 that I will think about. Okay? Maybe you got 0. Maybe you got minus. Maybe you got perfect score. But the reason why this problem is very nice, because to get a right answer, you have to think very carefully what is the basic concept of chapter 1, 2, 3, 4, 5. Otherwise, you will not get the right answer. Okay? Of course, you are ready to grade, evaluate my lecture. You guys will evaluate my lecture, right? Right? If I give this kind of hard question, I expect that you will give me a very low evaluation. But I often want to be evaluated very high, but I gave up already. I gave up already. But I think this is a very nice way to give you a motivation to think about the fundamental concept of each chapter. Okay? So we decided five problems already. And then I will give you maybe 2 another problems that requires to solve a certain problem. Okay? Okay? To get the right solution, you need to have the right fundamental understanding and the right skill to express what you think in terms of mathematics. Okay? So, back to this business. We want to convert V into P. Then what I need to use? Okay. The volume certainly related with the density change and the pressure. So, volume and velocity. Maybe I try to apply the conservation of energy in this case. So in the beginning, conservation of mass. In the beginning, the volume is occupied by this mass, rho zero V, and that has to be conserved. When I expand it, that means the volume is changed, and then the density is changed. Right? Maybe you could think that, hey, why don't you put minus over here? I just assumed the incremental increase of density as well as a volume. If that is wrong, then I will get minus delta rho. Okay? So this gives me and this is higher order term as we did always, and cancel out, and I have therefore what I have dv d rho dv d rho is related to rho 0 and v. Therefore, I can write rho 0 dv dt is equal to minus v d rho dt. Therefore, now I can argue that Ca dp in dt is equal to minus v over rho 0, and I have a minus over here, and I have a minus over here, d rho dt, and then using dp in d rho, isentropic process is c square. So I convert this rho 0 d rho dp in dt. Therefore, this is 1 over c square. Therefore, I got with rho 0 c square dp in dt. So this is compliance. Okay? So we finally get the compliance is proportional to total occupied volume and the density and the speed of sound. Okay, now I can calculate the compliance. Now, so the business I have done is I got this equation, and then I calculate the compliance. Okay. What essentially I want to have is the relation between P out and the response. Okay? So I have to look at what happened in this mass. Okay? The net force acting on that mass would be P out minus P in area. That is the force acting on the mass, which I have to define, of the neck. Okay? So mass of the neck. Mass of the neck will move according to the Newton's law applied to this mass. The force acting on this side and the force acting on in that side, that is P out minus P in multiplied by the area. That has to be moving, that causes to move the mass of the neck, that is rho 0 L, and du dt, and the u is the velocity of a particle, fluid particle of the neck.